Hello, let's look at this question on quadratic equations. Find the range of values of k for which the equation x squared plus kx plus 2k equals to 3 has no real roots. Solution. We have the equation x squared plus k x plus 2k equals 3. It is not yet in the standard form ax squared plus bx plus c equals 0. This is the standard form. So we'll have to make it first of all in this standard form. All right, so all we need to do is to take this 3 from the right hand side to the left hand side. So we'll now have x squared plus kx plus 2k minus 3 is equal to 0. It is now in the standard form. So here our a is the coefficient of the x squared term. Our b is the coefficient of the x term. And our c is the constant term. We have 2k minus 3, the term that do not carry x. Once all of these are collected without any mistake, we can now go ahead now and check now the situation for no real roots. When do we have no real roots? Remember, no real roots also means that the roots are imaginary. If the roots are not real, then they are imaginary. Okay, so for imaginary roots, the discriminant b squared minus 4ac must be negative. Okay, for imaginary root or no real root, the discriminant must be negative. Now we know our b, so that means k squared, b is k, minus 4 into a into c must be negative. Let's open this parenthesis. We have k squared, negative 4 multiplied to 2, negative 8k. Negative 4 multiplied to negative 3, positive 12 is less than 0 or negative. All right, we end up with this quadratic inequality. So the next thing to do is to factorize the left-hand side. We have to get two factors of 12 whose sum is negative 8. And those two factors are exactly negative 2 and negative 6. So let's replace this negative 8 with negative 2 minus 6. So we'll have k squared plus negative 2 minus 6k plus 12 less than 0. All right. So we'll open this bracket. We'll have k squared. Open this parenthesis with respect to k, minus 2k minus 6k plus 12 less than 0. Factorize the first two and the second two. If we take the first two, k is common. So we'll have k minus 2. The second one, negative 6 is common. Negative 6 into k minus 2 less than 0. All right? It's always advisable to check if your factorization is well done. If you multiply this out, do you get this? If you multiply this out, do you get that? So k multiplied to k squared, k multiplied to negative 2, negative 2k. Negative 6 multiplied to k, negative 6k. Negative 6 multiplied to negative 2, negative, negative, positive. 6 times 2, 12. So the factorization is correct. Here we see k minus 2 common again. So we continue with the factorization process. K minus 2 is common. So when it's removed from here, we have k. When it's removed from there, we have negative 6. Finally, we have expressed that quadratic inequality in factorized form. All right, we have the product of two things being negative. So we have to proceed by getting the critical points. Critical points are, if we just continue up here, critical points are, you set this equal to 0, So you have the first critical point, k equals 2. You also set the other one to 0. That will give you the second critical point, k equals 6. We now go on the number line. We indicate our points. Okay. So we have 3 zones to check. This zone, and this zone. How do we check? All we need to do is to take values from each zone and we place them in this expression. And take note of the final sign. So a value from here could be, that's a value to the left of 2, could be 1 or 0, all right? Any value to the left of 2 or any value before 2, for example, 1. We will take 1 and place here, all right? If we take 1 and place here, uh, we have 1 minus 2, 1 minus 2 into 1 minus 6. 1 minus 2 is negative, all right? We have negative. 1 minus 6, negative. Negative multiplied to negative, positive. So that zone is positive. Now we take a value in this other zone. This zone here, a value here could be 3. Any value after 2. 3 is a good example. We put it in that same equation. So we have 3 minus 2, that is positive. 3 minus 6 is negative. So we have positive multiplied to negative, we have negative. All right, we take a value in this zone. The value there could be 7, any value after 6. So we will take, for example, 7. 7 minus 2 is positive. 7 minus 6 is positive. Positive times positive, positive. Now, we're interested in the result that is negative. Less than 0 means negative. So where do we have negative in our analysis? We have negative in this zone. Therefore, our solution set, okay, after getting the critical points and doing the analysis that we have up there, so we have our solution or range. We have to find the range. The range of values of k will be all values between 2 and 6. So we'll say 2 less than k less than 6. That is the range of values of k for which this equation will have no real roots.